Welcome to the Neurostimulation Podcast. I'm Michael Passmore. Today we're talking about a really interesting topic, metacontrol, which is a way of describing the brain's ability to tune between persistence and flexibility. My guests today are Professor Bernhard Hommel and Professor Lorenza Colzato, and they and their team have just reported a really interesting study indicating that paired anodal tDCS over right inferior frontal cortex, in addition to methylphenidate, can reduce cortical noise. And that it seems to be indexed by a rise in the aperiodic EEG exponent. Lots of technical terminology, but we'll have an opportunity to unpack all of that today. And the important part of the study was that it was found to be occurring specifically during task processing and not merely at rest. And so I'm looking forward to talking more about this because the findings included things like the effect centered over mid-frontal electrodes, so FCZ, and it grew when stimulation and medication were combined, which suggested partially convergent mechanisms on signal to noise in cognitive control, which is extremely important in terms of enhancing our understanding about disorders that affect attention and other aspects of cognitive control. So we're going to unpack what things like aperiodic activity is, why metacontrol matters for real-world functioning, and what those findings might mean for treatment of conditions like ADHD and obsessive compulsive disorder, and for the future of things like biomarker-guided non-invasive brain stimulation. And so, as usual, I'm going to put links to the study and other content that the team has on the net, and you can feel free to check that out. I would encourage you. And then one last thing before we say hello is that a quick reminder is that, as usual, these conversations are for education only, and it's not medical advice, and we're not endorsing any kind of unsupervised use of brain stimulation devices or drug device combinations outside of this clinical research setting that we're going to discuss today. So once again, thank you, Professor Hommel and Professor Colzato. Thanks so much for joining us today. Really looking forward to an interesting conversation.
Yes, thank you for the invitation.
Thank you. We are pleased to be here and to have this conversation with you.
Yeah, I'm really looking forward to it. Maybe we could start by you sort of introducing yourselves and explaining a little bit about your background in terms of your research interests to audience here, and that would be very helpful.
Yeah, I'm Bernhard Hommel. I'm originally German. I'm still German, I'm afraid. But I then worked at the Max Planck Institute in Munich, then went to the Netherlands. We together went to the Netherlands, working at University of Leiden for 20 years. And then with a brief encounter in Dresden, Germany, at the Technical University, we went to China, where we are working now, in Jinan, in the province of Shandong. So far away, and there we are both interested in cognitive control, and well, I will explain later, but especially the combination with individual variability. So we all differ, and we try to combine this kind of differential approach with a basic cognitive science or cognitive neuroscience approach. So, but first you.
Yes, I'm Lorenza Colzato. I'm Italian. I studied psychology at the University of Padova in Italy. Then for my PhD, I moved to the Netherlands in Leiden, where we worked together. And then after that, we moved for 3 years to Dresden, and then from Dresden to China. And as Bernhard, I'm very much interested in cognitive control and in means to enhance or decrease certain functions. So I'm very much interested in the neuromodulation of cognition using non-invasive brain stimulation or pharmacological manipulations.
Mm-hmm.
Fantastic. Yeah, thanks for that introduction, both of you. It's so interesting. We were just talking a little bit offline about these kinds of approaches, how there's been just such a explosion in breadth of non-invasive neurostimulation techniques in terms of research and then clinical applications as well. And so this topic of meta-control, so for viewers and listeners who are new to this particular topic, maybe if you don't mind, could you offer a working definition of meta-control as it relates to this idea of balance between persistence and flexibility? It seems to me very interesting in terms of how, not only in the research setting, but then how that likely would apply to clinical applications, whether it's medication and or neurostimulation.
Mm-hmm. Yeah, perhaps it may help if I tell a little bit about the background, so where this comes from and why we kind of ended there, as it were. So I was working with colleagues in Munich on the relationship between perception and action, and we built a model that is still, I think, the most comprehensive model of this connection so far. And then the next question, and also kind of reinforced by Lorenza, who is a clinical psychologist by training, the question then is, okay, if this is a general model, what do we need to build in order to account for individual differences? So some people are doing things a little bit like this, others like that. So for instance, I worked on the Simon effect, a very simple-minded, boring effect, but I had two very famous colleagues, one in Italy and one in the US, and they always had the same experiments, of course, and then they had very different effect sizes. So in the US, the one of this, let's say the size of the effect would be around 6, 7, 8, 9, 10 milliseconds. I would typically have 17, almost always 17, 18, and our Italian colleague had 30. So how come, if you do hundreds of experiments, how come that you always end up like this? So, and questions like that, or if there is variability and so forth. So the question was, what do we need to build in? And then the idea was that there are probably two ways to build it in. Namely, one of the facts of the brain is that it is highly competitive, meaning that if you have gains somewhere, you have losses elsewhere. This is in terms of structure, it's a term of process. Even the retina is driven by this principle. So this is one, and it could be that this competition is sometimes stronger in some people, or sometimes in the same person, but other times for the same person, it's more versus less. And the other is that we are goal guys. So most of our processes are somehow affected, if not guided, by our goals. Now you can elaborate on what the goal is, but it's clear that it is driving us somehow. And again, this drive could be stronger or weaker depending on the circumstances. Now we had these two things, and then we thought about, okay, what does that do? So if you think about it, if you loosen the competition, you make, let's say, distributed representation more likely. You allow for more representations to live with each other. And when would you use that? Would you need that? Well, if you're thinking about, let's say, open box situations where you want out of the box, where you think, oh, how else could I spend my day? Okay, I always do it like A, but what else could I do? Then you don't want strong competition. You want many possible alternatives to coexist. Whereas in other situations, like if you give me a very challenging task where you say, I bombard you with stimulation, but you only are to report this stimulus and you ignore everything else, then I want the opposite. I would want to have strong competition and very, very high focusing on only what is relevant. So the goal should determine what I see or hear or do. So different situations call for different setups. And if you assume that, let's say, the maximum of goal-drivenness and competition could be called persistence because it is focusing you as much as possible on something, versus the opposite, relaxing all the constraints, opening up to everything else, is doing the opposite. That's what we call flexibility. You can imagine that there is a meta control, as we call it. So because the type of control is determined by this. And you may imagine that this is one dimension moving from one pole to the other, depending on circumstances or requirements or task requirements, whatever. But it could also be, and there is actually evidence for that, that some people are more at home on one part of this dimension and others are elsewhere. So all those admin people who love Excel sheets are certainly in need of a lot of persistence, and they probably are born like this with this bias, whereas artists probably have the opposite, very loose. They are often not very straightforward in their thinking, but that makes them creative at the same time. So this was the general idea, to develop something on top of control that determines not whether I control or what I control, but what style I prefer when doing the controlling.
Yeah, thank you for that explanation. It's fascinating. There's so many things that have come to mind when you're describing that. I mean, I guess I have a bias as someone who's interested in cognitive psychiatry, cognitive neuroscience. And over the years, I've come to wonder if even, I'm going to get in trouble with my mood disorder colleagues, but if even things like mood disorders are to a large degree cognitive disorders. I mean, I think there's been interesting theory around psychotic disorders being conceived of as properly core cognitive disorders. And so what you're explaining made me think about a couple of things. It reminded me a little bit of Ian McGilchrist's description of sort of brain lateralization issues in terms of focus versus more broad awareness. And then also what you've just recently brought into the discussion there made me think about how the cognitive and metacontrol and the sort of variability is kind of going into the territory of different temperaments and different personalities, and how those overlap. Yeah, and I guess that fits with this concept of what I understand that you've called non-bivalent psychopathology because of that spectrum type framework, I suppose. Yeah. Yes.
Well, I mean, the logic is, I think, straightforward. If you let's say, want to explain or account for individual variability, for the fact that you do things differently than I do, and so forth, then the question is, what is psychopathology? This is just you transform something from a kind of a feature-based sorting into a continuous dimension. And because on this hypothetical dimension of metacontrol between these two poles, there is no border or no area where you say, oh, you're leaving the British sector or something, or the safe sector or the sane sector. And that means two things. Well, first of all, what we try to do is to account. So we are not happy with the phenomenologically based categorization of psychopathologies, because, I mean, historically, people start somewhere. They're only interested in one pathology. Someone else is interested in another. Who tells us that what they are busy with has nothing to do with each other? Well, the fact that DSM is showing these things on a different page would be much more convincing if we would know much better about the physiological and brain-wise underpinnings, which we most of the time don't. And at the same time, look at all these psychopathologies. They almost always have something to do with neurotransmitters. How come, if they are so separate, so different, how come that they have very similar features and characteristics? So this makes us very, very skeptical about phenomenologically based. So people have just limited ways to describe their experience, often language-based limitations, right? So people think it is good to describe it like this, but you could also describe it in very different terms. The different languages have slightly different emphasis and so forth. So what does that mean? It means that you can do this, but it's very unlikely that, let's say, language and other phenomenological categories tell us much about what the brain cares about. It's very unlikely that the brain thousands of years ago said, oh, there is a category like this, I better, you know what I mean. So the question was, how can one make a continuous model that allows for, nevertheless, for different psychopathologies to be captured without deciding, oh, these two pathologies have something to do with each other, and these are not. Let's be open with respect to that. And let's also be open with respect to the borders. So perhaps we all are crazy to some degree, and under some circumstances, I may be depressive, and under other circumstances, I may be what else? But fortunately, I'm getting out of this quick enough for a doctor not to diagnose me. But that does not mean that the processes underlying it are very different. So perhaps we all can generate these processes, but some fortunately do less so than others. And if that is the case, then you end up with two conclusions. Namely, one is that the difference between healthy or normal and abnormal, psychopathological, atypical, or however you call it, is not very clear, okay? And second, it also means that if we can redescribe psychopathologies on this Metacontrol dimension, being in very extreme in the direction of one pole means that I'm very bad with respect to all the things that require the other pole. But it also means that I should be particularly good with respect to quite a number of things that are related to the pole I'm attached to. And that is, if you read very closely the literature, that is what you can demonstrate, namely that they overperform with respect to healthy controls. So all the pathologies, the big ones, can be demonstrated to generate people who are particularly good with respect to some tasks if the tasks are close to one of the poles that they are attached to.
Yeah, that's fascinating. No, I mean, thanks for explaining that. I also share, to a certain extent, your skepticism about the phenomenologically based way of diagnosing mental illness. And I guess, it's interesting because I can remember as a resident thinking about wondering somewhat, I was curious because I noticed that senior colleagues tended not to bother too much with the checkboxes of the DSM. And as residents, we were kind of forced to in order to pass our exam. Right. And now 20 years later, I can kind of see, because I'm more kind of agnostic about the checkboxes, because I realize there's all these different incentives. Like, obviously it's better for the drug companies if there can be a checklist for a busy clinician to just check off a few boxes and then prescribe a medication. And then insurance reimbursement is sort of incentivized to have these kinds of, what would you say, like the categories that it's sort of easy to slot people into. But it's also something that I've noticed in terms of clinical experiences. There's a tendency to, you're not supposed to ask leading questions, but you have a checkbox in your mind. And so, the leading questions kind of almost happen by default. So it's no wonder that patients are also kind of dissatisfied with much of psychiatric care and much of what medications have to offer. And another reason why it's really exciting that what we're seeing with neurostimulation options and even combining treatments like neurostimulation with medication or neurostimulation with cognitive behavioral therapy is going towards like a tailoring or a personalization of treatment, which kind of goes along with what you're saying in terms of the personalization of diagnosis as well, as opposed to that phenomenologically based approach.
Yes. Yeah. Very important. Yeah, I think, and this is something, first we thought that when we start submitting papers with this undertone, that it would meet pretty much resistance especially from the psychiatric side, and the opposite was the case. I think these people were because I think most reasonable doctors know or feel that it's not ideal what they're doing, but they have no better idea. And of course, they want to be scientists and they want to follow some rules and some logic. So it makes sense that they are using whatever is provided by the important societies. But at the same time, I think most of them, the more practical they are busy, feel that there is some limitation. And I think almost everyone would agree, even in the non-psychiatric medical sector, would agree that personalized and much more personalized medicine is absolutely crucial. It's just, how do we advance the science in order to get there? So the challenge is much bigger than the understanding. No, that's not what I want to say. The understanding is good, but the question is where to go. So the support for for our papers, it was actually amazing.
Yes.
So we had very positive experience and no defensive
Especially for
observations.
the last article.
Yeah,
Yes.
yeah.
Except maybe this is a funny anecdote. Actually, the title was not bivalent, but was non-binary, and
Okay,
we had issue because of using this terminology
With the gender.
With the gender, which
Oh
seemed,
dear.
I mean, for a European, this is absolutely not an issue, but probably the reviewer was American and say, no, this is the terminology is too vogue.
Yeah.
Absolutely, you have to
Yeah.
change it. And it was a little bit
Yeah,
peculiar for us.
That was funny.
A funny way, because for us, it has not necessarily
A gender-related meaning, but yeah, these are the languages
actually,
and the
I think
differences
that
between
actually
them.
non-binary would be a better
It would
terminology.
it would fit much better. But anyways, this is the editorial logic that we had to follow.
Yeah. Well, that's interesting. And so I can see how that came about. So that we'll use non-bivalent.
Yes.
And so I mean, I think maybe that's a good segue into helping us understand more about the study involving the anodal tDCS over inferior frontal gyrus and then combining with methylphenidate. Do you mind walking us through about basics of the study sort of design and then the results that you found?
Mm-hmm.
But actually, the design was not done by ourselves because that was actually already been done. And what was at the University of Dresden, and what we actually did, it was a reanalysis of our study, of this study using aperiodic activity. So what our colleague did is they use an intensity of 2 milliampere of the anodal tDCS, which is the standard dosage used in many studies. And for MPH, they used P75 milligram per kilogram, which is considered a pretty high dose, I would say, at least in Europe, which, if you think about, if you're 70 kilogram weight, then you would get 52 milligram, which is considered, some quite.
Yeah, and perhaps just to explain, we were particularly interested in the past. We did many reanalyses for the following reason. Most of the EEG researchers are extremely interested in periodic activity. So most readers or listeners may be familiar with alpha, beta, gamma rhythms, which refer to the fact that our neurons fire in particular synchronized ways that can be characterized by describing the frequency or the frequency band this falls into, and that rhythm is assumed to underlie communication in the brain, and therefore it makes sense for a neuroscientist or cognitive neuroscientist to analyze them. So, and that means that many studies, of course, have been done with a focus on these periodic activities. However, we find that the metacontrol, as I described it, the aperiodic activity is even more interesting. And given that this is typically ignored because most researchers believe, oh, this is just a measure of noise. If I take all your brain activity, if I take out all those rhythms that are supposed to underlie communication that is meaningful, what is left? Well, just noise. And only very, very recently, there is from physics actually coming the idea that noise might be particularly useful for some situations, not for, I mean, a totally noisy brain would be very useless for us, but sometimes being noisy is good. And this sometimes can be connected theoretically to the Metacontrol story. So that's why we are particularly interested in studies that we already have, or that others have already done and reported, but we redo the whole thing with a totally different perspective, namely on noise. So just,
exactly.
to explain why we did this.
Yeah.
Yeah, no, that's very helpful background. Sometimes it's the things that are ignored that you know can lead to the serendipitous findings and improved understanding. So that's really interesting. And I'm curious about, I don't just maybe also for me and for anyone listening and watching that doesn't have experience with the actual tasks or the Simon and the go no go paradigm. So can you just explain a little bit about what that was in terms of the subjects in the study?
Sure. Yeah, the go no go is simpler. So this is one aspect that you can combine with other tasks, but the general idea is I present you with at least two stimuli, let's say an X and a no. And whenever it is an X or a blue versus red dot or something, whenever it is one, then you press one key in front of you. So it's embarrassingly simple. And you do it as fast as possible and as accurately as possible. So we measure reaction time and error rates. So not pressing the key, even though you should have, would be an error. And there is a no-go. And the other stimulus, whenever I present this one, you should not press the key. And even though that sounds even simpler, it is not easy because, of course, we play a little trick. Or the people who originally ran that, but we also do that regularly. Namely, we make the go much more frequent. So you are kind of set to press rather than not to press. And that, of course, makes it very easy to kind of automatically press even in the case of a no-go response. And that in turn means that if you are doing well, if you are making no mistake, then you have to hold in check your response, which must be much more difficult in the no-go condition than in the go condition. So the no-go here in this particular setup is the real challenge, is the more cognitive control heavy aspect of the task. Now, this is the go no go. So you can also change it. You can make the go and no go equally likely, or the no go more likely, or whatever. Then you change the character of the task. But we always use this kind of task for this. Okay.
Yeah, that's the frontal disinhibition kind of thing that we would.
Exactly.
Yes,
we would do in clinical testing. Yeah.
Yes. Because we believe that, and we can find this, that if the no-go is much more challenging in this particular setup, then you should denoise your brain more. You should be wanting to identify the signal and not the noise, and therefore you denoise your brain as much as you can. And this is indeed what we find in the exponent, in the FOOF exponent, as it is called. This is also taken from physics. And it analyzes the amount of signal to noise ratio, some would say, others would say the amount of noise versus noising versus denoising your brain, and so forth and so on. So whenever you are presented with a no-go signal, you see a much bigger flank rising in this exponent, showing that you denoise your brain much more than with a go signal. So this is one aspect. The Simon aspect is a little bit more complicated, but not much. So I could present this stimulus I could give you, let's say, two keys, left and right, and then present the stimulus, and then let's say the left key is signaled by an X, the right key is signaled by an O or something. And you could mix that with a go, no-go logic. But in any case, in the standard task, all you do is you randomize the location of the stimulus. Sometimes you present it on the left, and sometimes you present it on the right. Now, what happens, and what you could imagine yourself, is that if I have to press left, it's easier, more convincing to me if the stimulus also appears on the left, and it's a bit harder if it appears on the right, and the opposite holds for the right response. So in other words, we kind of automatically decode the location of the stimulus and seem to match it with the location of the response, which for our stimulus response, I said that in the beginning, this was the beginning of my career. I did a lot of hundreds of Simon tasks. And the reason is that this tells us something about the relationship between perception and action, that they are not independent, that they are not kind of totally decoupled, but they always interact back and forth, back and forth. And this is one very simple example of how you can measure the degree of this interaction. So these are the two aspects. The Simon, you could also make predictions regarding to Metacontrol. You could say that the incongruent or incompatible condition, namely where the key is on the opposite side of the stimulus, is more difficult, more demanding. And so the Metacontrol measure should show a greater denoising of the brain. And this is what you find, even though this is not always significant, because the Simon effect itself is pretty small.
Yeah, amazing.
So we use it as an indication of Metacontrol,
yes.
And we use it in several studies. So this is why we are pretty confident that it actually...
Yeah, especially the go, no-go works pretty well.
Yes.
You can perfectly replicate that over and over again. So we looked into many studies and did some of ourselves, and that's always what you find. If you do this, if you increase the frequency of the go, so that the no-go is really more demanding regarding control.
I see. So the reanalysis that you're describing in this particular study,
yes,
it seems, so the core result was that the tDCS reduced that cortical noise, or I guess you could also say it increased the aperiodic exponent, but only when combined with methylphenidate. Is that correct?
Exactly. So that logically or theoretically, both of these factors, namely the brain stimulation and the medical, was chosen because both of them are assumed to operate on the signal-to-noise ratio. And there are findings suggesting that. Now, that's why we thought, okay, why not using both in order to see whether they potentiate each other or whatever. But the opposite was the case. You see a kind of under additivity. So in other words, the stimulation increases the exponent, which means you denoise your brain, so it produces less noise. And the same goes for the medical treatment. But if you combine them and then you would expect the best denoising situation if the medical treatment is combined with the brain stimulation. But this is not as high as you would expect. So that's what one would call an under additive combination. It's not that one adds the exponent and the other is also adding something to the exponent. So if you add both, you have the highest value. No, that's not the case. It is as if there is an upper limit, perhaps a physical, logical limit that physics people may even mathematically describe, namely, you cannot denoise your brain endlessly. So there is some limits, some order cannot be logically achieved. And that may also differ from person to person. That we cannot judge from this particular study because we have too few data for each person. But on average, you see this under additivity, which means that there's only so much we can do. So if you say, I mean, there are many questions to be resolved before one can turn that into treatment. Sure. So we don't know how long this is lasting and so forth. This is something we are looking into right now. We're kind of stretching the time more and more. But even if that would be resolved, we cannot, let's say, we can only hope to achieve so much. So things will be better with the medication and it will be better with this brain stimulation. But whether this achieves extreme levels, we just don't know. There seems to be a kind of hardware-like limitation.
Yeah. Well, it's interesting as well because it makes me think, because of what you were saying at the beginning about the importance of the balance between persistence and flexibility to be suited to whatever is in real time the person's experience. And so I would imagine that something like cognitive behavioral therapy could be an additive kind of an approach too, to be able to help people to learn in different situations how best to kind of approach it and have that balance between persistence and flexibility, particularly in like a school, like a learning setting, or learning the skills in a new job or something along those lines, or social intelligence kind of things.
Yes. Yeah, I think there is, we were also surprised over the years because in the beginning, so some years back, I was intuitively, I thought that, well, cognitive control is typically described as something that takes time. So if I look at task switching, which is assumed to tap into cognitive control because you change from one mindset to another in order to do something else, that takes quite some time. And the time it takes is often way higher, way more than the typical effects we have. So in task switching, if you compare task repetition against task switching, you do not get 10, 20, 30 milliseconds like with a Simon task, but you get 100, well, sometimes 500, 600, 700 milliseconds, which for cognitive experimentation person is a lot. It's a whole world. And that suggests, and then you can argue, of course, a mindset, let's say, includes many areas of the brain and rewiring and takes time and so forth and so on. But that's why I thought that Metacontrol changes also take enormous amounts of time. And then I hoped I could play with this by having people do, let's say, a persistence heavy task and then squeeze in a flexibility task and show that there is transfer, even though people, because of inertia, of neural inertia, as it were. But that's very rare. And it seems that people immediately attach changes of Metacontrol to stimuli, so that the stimulus at some point is driving the change itself, which is, of course, very smart. You kind of delegate the control or the control of the Metacontrol to your environment. But yeah, I was surprised by that. But that's again, we the closer we look, we also find that all these Metacontrol changes are only initiated by the stimulus. Of course, if you do the stimulation, you can find main effects. So it does change your brain, let's say, during the whole block. Typically, you switch on the apparatus, and then for, let's say, 20 minutes or so, and then you're continuously stimulated. And during that time, of course, there is not much change, and that elevates or reduces the level of the FOOF exponent as a main effect of that block. But it hardly interacts with the stimulus. The stimulus is really the driving guy, which kind of makes the really interesting changes, as if people would immediately outsource their control.
Yeah. as a meditator, it makes me think that perhaps people who have experience with meditation might have some sort of awareness, because the language to me sounds analogous, this idea of metacontrol, or having some more sort of awareness or mindfulness about how one is actually controlling the executive function that underlies thought, I suppose, in its basic terms.
Yeah, I would assume. I mean, that's why we did an fMRI study. We did many studies with meditation, but typically with naive participants, until we found that the effects become smaller and smaller and eventually disappeared. And then I thought, what's this? And then we asked our experimenters, and they said, well, first we attracted all the people who are enthusiastic about meditation. But now you guys ran so many studies that now all we get is people who are totally disgusted and don't believe a word from what you're saying, and who knows what they are doing. So whether we properly manipulated the things we wanted to manipulate, one can argue about a lot. So that makes replication very, very difficult. That's why we, in a recent study, we actually asked experienced meditators who are from a school or a kind of forum where people meet and exchange their experience. And that was much more, let's say, stable. But again, I think everyone then has a particular strategy to get into one or the other meditative mood, and perhaps they are not even comparable. So that makes it scientifically very difficult, because you don't have the size of you don't have the necessary power to compare the strategies.
Yeah. Well, I think, I was also thinking from a clinical perspective. I was really gravitated towards the aspects of the discussions in the paper that looked at how linkages could be perhaps conceived of between something like ADHD and higher cortical noise, so more of a flexibility bias on that spectrum. That what was the term that we were supposed to use now? The bipolarity, or not anyway.
Whatever you want.
Yeah. So the ADHD, higher cortical noise, the flexibility bias versus OCD, which would be the persistence bias, more towards that. So I was just curious, how would you differentially then use metacontrol informed interventions like tDCS or stimulants, behavioral therapy, that kind of thing?
Yeah, I think for ADHD, indeed, this kind of stimulation that we've done, combining MPH with anodal tDCS, would be ideal. But in the case of OCD, which is gravitating towards more persistent, and probably they have already a sort of sticky, so too less noise in the system, would be ideal to use transcranial random noise stimulations, which is a relatively novel, non-invasive brain stimulation, which is able actually to enhance the noise in the particularly part of the brain where the electrodes are used. And there is actually a new study, I think it was in PLOS Biology, which they made this fantastic link between transcranial random noise, and they measured the aperiodic exponent. And indeed, they found that increased the noise in the brain. And that might be, of course, with OCD, the literature regarding aperiodic activity is not very much developed, but that might be a working idea to test the hypothesis that transcranial random noise might be helpful to make OCD patients more flexible, to help them to bring them away from their stickiness, right?
Yeah, we actually started already just recently started to look into some open source data sets. But there are two problems with this. First, it was very disappointing because almost always they showed, I think, remind me, I think less noise or more noise.
More noise.
More noise. Almost everyone. So even those pathologies that we thought should be on the persistent side, but the problem, there are two problems. Number one, if you get EEG data, then you typically get resting state data, and resting state data can only look into trait-like preferences. So, and what we, however, and we do have some few studies where we could predict a little bit of the variability by using resting state as well. So there is a trait component, but in comparison, the state, so the task-specific state component is much bigger. It's producing much bigger effect. So you do find these tiny effects. So if I stimulate your brain with tDCS, you kind of reduce the noise a little bit, and that is even true before the stimulus appears, right? So just in between the trials, your brain is just a little bit more denoised, and that could be also even in the resting state. But once the stimulus appears, boom, it goes into a totally different direction. As if it is not that there is no standard mode or something that matters so much, but it is a kind of setting how to process things once you process them, but not before, right? And if you have then only resting state to predict, you don't know how little the contribution of this predictor might be. And typically, those open source data do not contain meaningfully set up tasks that allow us to kind of compute our FOOF exponent. Second, typically what is not reported, they report the diagnosis very specifically, different kinds of ADHD, of autism, and so forth and so on. That's all fine, but they typically do not report whether people are on or off medication. Now, of course, if I give you the right medication, then ideally you should behave like a healthy control, and then we find no difference, and then we are disappointed, but that makes no sense. So this makes it difficult. That's why we are now planning bigger studies ourselves. But of course, then we have to get in touch with hospitals in China and battle with the language and make sure that the instructions are properly understood by Chinese-speaking participants and so forth and so on. But nevertheless, we have to do this. Otherwise, the data are not of a quality that we need.
What is maybe fun to know about China, they have a big negative cultural bias towards pharmacological interventions, but not towards brain stimulation. Yeah. So they almost don't prescribe MPH for ADHD children, but they go immediately with the TMS.
Some run around during the whole school time, and the teacher is kind of monitoring their attention through a monitor and saying, "Oh, you're currently distracted," and they love it. They think, and then if you interview them, of course, in Germany they would say, "Oh, you're controlled by the country and the government and so forth and so on." But if you interview the pupils, they say, "But isn't it great? They help me to make me even better." And so the perspectives differ dramatically.
Yeah, that is fascinating. That's an extra fascinating aspect of the conversation are these cultural differences in terms
Absolutely.
of approaches to,
Oh yeah, fascinating, because they believe, of course, in traditional Chinese medicine and in acupuncture, and there is also this electrical acupuncture. Sometimes we're doing also transcutaneous vagus nerve stimulation, and we explain this, hey, it looks like acupuncture, this is here, and you put simply an electrical impulse, and this is way more acceptable for them as taking a psychoactive medication. So what, for example, in Germany is the other way around. I think especially for children, MPH has been prescribed very easily But the idea of giving electrodes and putting electricity is
people go crazy.
Yeah.
Control.
Yeah, so it was very fascinating to see these these cultural opposite directions.
Yeah, it is. It's very interesting. I mean, again, without coming across as overly conspiratorial, but it's just a part of how I think there's perhaps this unintended consequence of the pharmaco-industrial complex, in North America and Europe that sort of guides the learning curriculum for clinicians, and then that's kind of just how the practice is sort of structured. And because your neighbor is doing it the same way, and the guidelines and the research, it's all kind of there's some kind of capture, I guess you would say, So it's fascinating to see how in a society where perhaps there's not the same kind of capture, maybe you could argue a different type of capture, but it's not going to steer people towards different treatment options. But the beauty of it is that, and as you're explaining here, and so fascinating because of your real world experience in China and then also in Europe, is this combining the best of both worlds, really, is what we're looking at, right?
It's very enlightening.
Yeah, absolutely.
For sure, yeah. We're getting close to the end here, but I was just thinking one thing that has been coming to my mind over and over again is this importance of the task specificity in terms of metacognition, I suppose you would say, not only in this kind of research setting, but also obviously in the real world setting. And also how, Dr. Hommel, that you were just describing this idea of a very rapid ongoing kind of feedback loop that's happening with the attention to the task, and then the feedback that the individual would just have automatically happening, so that would kind of keep them on course. So does that seem to be an important component of the findings, and how it would be applied to real world settings?
Well, obviously, I mean, ideally, you want, let's say, if you want to avoid the, I mean, especially if you compare our classical medicine with, let's say, more traditional or nature-related approaches like the Chinese traditional medicine, there is an interesting difference in the role that patients play. Namely, they are, in the traditional one, they are the agent who believes in self-empowerment, whereas our often much better functioning, I'm afraid, especially if it comes to cancer and all these nasty things, but it degrades the patient into a very passive role of the eminent doctor who tells you what the truth is, and then you have to follow the instruction and so forth and so on. And this is what certainly the anthroposophical approaches in Germany are particularly interested in, and what they find appalling is this kind of degradation of patients into a passive role of receivers. And so in the end, what we should want is not only to understand how Metacontrol works, how it can be improved, let's say optimized. I don't think one can optimize things. This is against the Metacontrol logic, but for particular situations and for particular tasks you can optimize. But to give that under the control of the agent. And for that, and that's why we are currently working on a direct neurofeedback loops, where we have a very talented student who is mathematically very skilled to optimize the speed of how much you can, let's say, take out of the EEG cap and feed into a game or some display that allows you to change, let's say, to drive the rocket or the car in there or there. And by doing so, you actually drive it with your Metacontrol FOOF exponent. So once you master that, and again, we do baby steps. That's the very first study. We have to do all the validation and everything. But the idea is to provide people with a very fast feedback loop that allows them to control their Metacontrol parameters themselves. at will. Of course, currently this is too clumsy, too big, you need lots of apparatus, but basically you need only one electrode or two, because we always find one area to be involved. That's relatively easy to pick. This could be mobile, and if the display could be very simple, that could be connected to a smartwatch. So people could very easily, I mean, of course it looks funny if you have, but well, people will get over this if they have really big problems to tackle. And certainly in China, they wouldn't mind at all to run around with a headband or whatever. But this is what we are currently at. I cannot yet report. I mean, it seems to work in some people. So we have pilots. But of course, this is only a promise, and I hope in 1 year or so we have much more interesting data to offer. But you're certainly right. I mean, basically, this is the way to go if you want to leave it to the people to make the decision what they want to do with themselves.
Yeah, especially with younger people, you know, giving them the agency to take control over their own health is a big part of improving their health, right? And not just having a passive approach, for sure. Yeah, and it's amazing because I imagine that the potential applications as far as this kind of brain-computer interface are pretty endless. It's fascinating.
Yeah. So
okay, well, Go ahead. Sorry.
No.
Yeah. Okay. Well, no. If you have, I mean, I think we're just kind of coming up to the end here. So if you had some final thoughts or you wanted to share something, that would be great. Yeah.
No, I mean, in general, I think what I like about this approach, again, there has been groundwork that needs to be done, but what I like about it is two things. First, to combine general insights into the laws of the brain and the neuroscience, to combine it with an eye for individual variability and differences. And that, of course, also covers the cultural differences in the end that we discussed, which become more and more important in research. And second, to become, let's say, much more specific with respect to the mechanisms. So not to start with phenomenological categories that we made up at home, that may be of some use, but perhaps not. But let's say to start the opposite way, to try to reconstruct from what we know about the brain, and that limits let's say the jumps that we can make because we only know so much, but it grounds our thinking much better than I think those kind of the opposite top-down approach. So these are the things that I think our science needs, and that's why we find this approach to be particularly interesting. But there may be many others. So everyone is invited to kind of revolutionize our science to make it better.
Well, that's great. That's a great way to finish off. Thanks so much for summarizing that. Thank you both once again for sharing your valuable time with us and helping us to understand this really fascinating research and all these potential applications, and as well as the cross-cultural aspects, which is fascinating. And I was hoping to talk a little bit about that, so I'm happy we were able to, and I just think it adds so much to a rich conversation. So thanks once again for joining us today.
Thank you.
Thank you for having us.
Yes.
Great. So that was our conversation with Professor Hommel and Professor Colzato. 3 takeaways for listeners: practice if you're clinicians, research if you're academics, or if you're a member of the public and are interested in neuroscience. So the first takeaway I would say is that metacontrol isn't just an abstract kind of concept. It can be modulated, and studies are showing that tDCS and methylphenidate can reduce cortical noise during task execution instead of just at baseline, that the aperiodic exponent is a promising EEG marker that tracks these shifts, especially at the FCZ area. But it does need replication and standardization, of course, as much of this kind of research before routine clinical use can be recommended. But these kinds of clinical applications are certainly on the horizon, and it's very exciting. And then the third thing is that that kind of translation is going to hinge on safety, but individualization that we spoke a lot about in terms of the neurostimulation. So the correct montage, the correct dose, the biomarkers that might suggest who are going to be likely to have positive treatment responses depending on different patient phenotypic factors. So again, I just invite viewers and listeners to check out the content from the lab that I'll put in the show notes, and this particular study, I'll put a link to that from the journal Brain Stimulation. Again, if you've enjoyed this, please like and subscribe. Please ask questions and leave comments in the comment section below. Anything that you'd like us to review in future episodes. And thanks again for joining us on the Neurostimulation Podcast. We'll see you next time. Thanks so much, both of you. Really appreciate it. Thanks for your time.
Okay.
Yeah,
we hope it's
think-
useful.
Yes, and
For
it has
sure.
been a nice conversation. So thank you
Yes,
for having
definitely.
us.
Thanks
Okay.
so much. Okay. Bye-bye. All the
Have a
best.
good
Bye
day.
bye.
Bye-bye.
Thanks, you too. Bye-bye. Thanks.